Yes, thank you. Welcome everyone. I'm going to tell you something about writing maintainable code in an ever-growing environment. I think it's something everyone has, growing code bases. First, a little introduction about me. Or I told it already, I'm Kai van Baarle, working at OGD ICT-diensten. We are an ICT, I should say, service provider with a software company inside of it. Since June of 2018, I'm the CTO of the software department. Before that, I've done a lot of things, and I've been part of the Silverstripe community from Silverstripe 2.4 till 3.5-ish. I'm not really sure when I stopped contributing to Silverstripe. Before I would start working at OGD, I've done quite a lot of things. I've once started about 12 years ago as a front-end developer. I went freelance after a while, helping companies improve their code bases. Eventually I got tired of that because I've seen too many shitty code bases and decided to join a company working with C# mainly. And there again, I walked into shitty code bases. I was thinking, what should I do now? And then I knocked on the door at OGD, and they were originally a staffing company. So while I was starting to work there, I got sent out to other companies, discovering more shitty code bases. The code horror. This is what an average code base looks like. A lot of Lego-like blocks. They all should fit together, sometimes fit together, block together, stick together, hard to get out. You know, the really small Lego blocks, the tiny ones, if you press them well together, you can't unstack them anymore. So this is, for me, what unmaintainable code base looks like. What do bad code bases share? First of all, they have no structure whatsoever. Code goes everywhere. I was talking with a colleague of mine a few days ago. He used to work at a company and they had this one big file of 9,000 lines of code with everything in it. Next to that, they had another file with 5,000 lines of code. So when you couldn't fit your code in the 9,000 line file, you put it in the 5,000 line file. Different coding styles all along, even in the same line. I've seen people use single quotes, double quotes, bracket placing, all different. And this was one single person writing code. And of course, the lack of any form of architecture. Not well thought through code. The last thing is probably to do with the way of work people do. I think many of you work in Scrum teams. Yes, no? People are quite quiet, so people don't work in teams? No answers? Okay. But if you apply the Scrum methodology, agility, in your process of forming software, you will apply some architecture in some way or another. Yes, and finally, bad code bases all share unreadability. If I join a company to help them improve their code, apply new features to them, I like to read myself into the code. And good code, maintainable code, is readable. It doesn't need comments, stuff like that. You can just start reading it and understand it all. But after all that, all those companies I've seen, I think it's more about 1,000 companies with a multitude of code bases I've been involved in. And I started wondering, why is this so terribly bad? And that brought me to the next point. What makes code maintainable? In my quest to finding out why all these code bases were so bad, I found one thing: they share it all. The meaning of the word maintainable differs from team to team and from person to person. A DevOps person has another view of maintainability as a sysadmin, or a DB admin, or a JavaScript programmer, or a PHP programmer. So first you have to understand what does maintainability mean for you. I've come up with a few things that help you understand what maintainability may mean for you. First of all, the code style and conventions. Does anyone here use any convention or style in their code? Do you apply them? I see many people have code styles and conventions, but not that many apply them all the way. At least have some conventions. You better have bad conventions you stick to than don't having any conventions at all. For PHP, there is a pretty good code style available. I think Silverstripe tries to apply it, PSR2. People are familiar with PSR2? If not, go read into it. It really helps you to get better. JavaScript has standard.js, Python got PEP3. Every programming language should have a code style given from the community. Some other tools that help you to stick to your code conventions are editor config. People know editor config. Look into it. It's a little tool you can add to your IDE, and it helps you settings like line endings, breaks, indent types, stuff like that, and enforce that from your IDE to your code. Next, architecture. What is architecture? For me, it has two parts in it. First of all, the code structure. That's how is your project built up? Where do you put your images? Where do you put your classes? Where do you put your data objects? These things should be thought ahead of before you start programming, and be shared over all the projects you do with your team or your company. So that if you switch projects, start up a new project, have new team members join your team, they know where to look, where to find what. Next to that, of course, the software architecture. How does it all connect? There are great design patterns for this to help you decide on your software architecture. Next to that, documentation. Many projects lack up-to-date documentation. Most of the time, there is some documentation written years and years ago, never updated, and not in sync anymore with the actual code base. Best start for documentation is a simple README file. The README file should say what kind of code styles you maintain, the project structure is like the architecture you decided on. Yes. Avoid overcomplexity in your code. Like I said before, code should be read like a book. If you have new team members joining your project, or you're handing over a project to someone else, it's a hell to go through all the code if there's no structure in it and if it's unreadable. Next to that, KISS. Are you familiar with KISS? Are you applying it? You try to. KISS is keep it stupid simple. More later about that. How many of you use comments in your code? Comprehensive code blocks. Yes, this here is magic. I don't understand it, but it works. It's evil. If you do this, stop programming, please. Because if you need comments on your code, it's too complex. If you need to explain what's happening, there's something wrong with your code. Code should always be self-explainable. I'm not a programmer to read comments, I'm a programmer to read and write code. Although there are exceptions. Doc strings. It's always fine to have documentation in your code that you can run a script by and print out your documentation of your API. Really helpful. Good tools for pre-page docs is an example for it. JS doc for JavaScript. And resources, matching, and other stuff like that should contain comments. Like if you have a magic number or something, or a string that you copied, or some method that you copied from the internet, it's okay if you do that, as long as you commented with the source why you applied it. Also, when you are using new techniques, not really known by your team, it's okay to put a comment on there for further reading. Unit testing. If you're talking about documentation, my point of view is that unit testing is one of the core documentations you should have. Why? Proper unit testing has all your edge cases written out with expected results. Reading through all the unit tests should give you a proper view of what the code should do, expected to do, and how it works. Writing proper unit tests is hard, because people tend to do the happy flow part and forget about the weird stuff, the race conditions that can apply. And it eases refactoring. If you want to keep your code maintainable, you should refactor. Refactoring is scary because you don't know what you are breaking. If you have proper unit tests in place, you don't have to be afraid of breaking stuff because your unit test will tell you something is broken. And of course, apply it in your CI pipelines. It's okay if you don't run the build as a dev on your machine. It's not really okay, but it's forgivable as long as your build servers are running your unit test and tell you, hey, we can deploy this, we can put this live because your builds are failing on the unit test. Next to unit test is replaceability. I've seen too many code bases entangled with packages for God knows why, and they are unable to get them out or replace them. Even self-written libraries are too entangled to replace. In order to replace certain code in your code base makes it unmaintainable, because updating stuff like that gets really hard. So don't lock yourself into libraries. It's okay to use them, like a framework from Silverstripe for the CMS. You don't want to write it all out by yourself. A good bad example is the leftpad story. Anyone use NPM? Anyone knows what happened with leftpad? Leftpad is a little library, I think it's 4 strings of JavaScript code. And the guy was angry on NPM for some reason, and he decided to delete his code. It broke 80% of the internet. And it took quite a while to resolve that. Many people are still using the fork of leftpad instead of writing those 4 lines of code themselves. Unmaintainable code, because irreplaceability. And finally, I like this quote a lot. Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live and is trying to kill you. Why is this important, to have this in your mind? This little creeper that knocks on your door if he doesn't understand your code. It enforces you to think of your code as something really important. It should be understandable, else you get a guy with a hammer behind you, like an American Psycho. By the way, this quote is from John F. Wood from 1991, I think, in some C++ compiler mailing list about the uses of the comma separator. A little tiny thing, and he got really mad about it. So, now it's time to get started with writing maintainable code. Are you ready? First, just going along some easy topics, easy things to pick up for writing code, reviewing, take it with you in your review process of the code you write or you see to improve it. For example, non-understandable variable naming. We have here variable A with an array of names. Any guesses of what these names mean? Could be Disney princesses. Could be girls from Beatles songs. I don't know. Now I've made it a little more clear. It's the top 3 most popular female dog names, according to some website. It doesn't matter. I hope it's clear that making understandable variable names is important. Same goes for methods. It's okay to write out longish strings to declare what you are declaring. This isn't what you see the best example, because I have hard-coded names in here. If you are talking about popular things change over time. So I would write an API for this normally to fetch those names for me, so I get always the up-to-date names. Or I should add a timestamp somewhere to either a comment or preferably in the variable. Another example of ununderstandable variable naming. My trends underscore cost is get trends underscore cost thing. I have no clue what thing is. If I look to this, I have no understanding of the word trends. And let's say I'm working at an airplane company. It could be transaction, transportation cost, transit cost, I don't know. Writing it out, instead of using the abbreviation, putting it in transaction, I understand directly what I meant with this code. And preferably I would change the word thing to something more meaningful, like package size or volume, according to the scope in which you are programming. Another bad coding example is unsure why some code works. Recently I had to write something down to do a Cartesian shuffle, and I'm not a mathematician. I don't know if any of you know what a Cartesian shuffle means, does? In short, you have an array, and an array of arrays. And you want to have the combination of all these things together. So you have to loop through the outer array and loop with that array through the inner arrays to get all the combinations possible. I needed this for some work, looked up Stack Overflow, and found this little code. But I still don't, eventually I did understand why it worked, but if you look at this, I don't think anyone can explain this code in 5 seconds unless you are a mathematician. So I changed a little bit. I added explanation in the comments above it and a link to the actual source where I found it. So I didn't want to understand it. I didn't want to explain it to my co-developers. I gave them a little hint. If you want to understand this, please go to this place. Here is where I found it. If you have any questions, ask them. I always like to talk about it in the abracadabra code. It's like a big bearded gray wizard sitting in the top of the mountains writing code. Nobody understands, only him. And you should avoid it at any cost, because wizards are not always present. You know Gandalf from Lord of the Rings? Sometimes he's there, sometimes he's gone. Then he's like, fly you fools, and he comes back as Gandalf the White. Totally different person. Yes. Same code again. You will see this example more often here, because I like it because of the complexity, and it shouldn't be this complex. First of all, the variables are not clearly named. We have a var r, probably result. Could be a convention, a max, a g, an l. We got the whole alphabet coming along, and a lot of scoping. Next to that, we got side effects, no proper returns. Any of you know what side effects are in code? No, side effects of code is changing something within or without the scope, without a clear definition of it. The example here is we got the var r is an empty array. Let's see, can I get my mouse here? We have here an empty array, and here we do stuff with that array. Changing this array without returning something is called a side effect, because we're changing something outside of our function scope, which is bad because you don't know what changes when, and you should avoid side effects at all costs. And instead, make little methods that return something which can be applied to such an array. Yes, next point is set variables where they belong. I see this a lot in JavaScript, maybe in PHP as well. You start a method, declare every variable you're going to use before hoisting, and then declare all your methods functions and use those functions to change or set the variables. It's bad because I can't see where variables come from. Back to the Cartesian shuffle code again. We see here a var max being used somewhere here. This could be a much longer piece of code, meaning I have to scroll back and forth to find my definitions of a variable. What I would do, I've changed some things between this part of code, is I define it before my for loop. I don't want it in my for loop, because then it gets set every time it runs, not preferable. And I change it to a max length, because max doesn't mean all too much. I changed some more bits. I changed R to result. I changed the J to a helper I, because I always stands for iteration. And now we have some more comprehensible code just by changing the order of the variables and the naming of them. Normally, if I would refactor code like this, I would strip out this part of code, put this call all in different methods. So I have single methods I can unit test and call in chain to get the same result. Next topic are magic variables. And we have our little friend back. Magic variables are like the magic numbers. For x is 3.14 blah blah blah. Okay, we are developers, we know 3.14 should be pi probably. But without any explanation, it's hard to understand why that number or the string stands in its place. At all costs, try avoiding magical variables. If you need them, put them in a config file or something. And if that is impossible, try to at least comment them how you get there. I once had a little piece of code found in a code base with a random number. For random number is 12. It took me a git blame to find out it was actually a random number. The guy took 3 dices, threw them, and the number was 12. Perfectly random. It's okay to do that, but at least put it in the comments how you got to your random number. Because if I like to see a random number, I would like to see some function or method applied to get the random number. Don't repeat yourself. How many of you apply the dry principle? About a third, I think. I'm not a big fan about the dry principle. Because people try to oversimplify things and apply the same piece of code to something that looks alike but isn't the same. And thereby you're making your code unmaintainable, because a dog is a dog, a cat is a cat, and if you both try to put them in the same object kind of style and apply the same methods to that, you aren't going to be happy. Or a dog and a horse, for example. Oh, please do repeat yourself, as long as the domain you're talking about differs. You can solve this by using inheritance and stuff like that. The inheritance part makes you apply the dry principle, and inversion of control makes it possible to change it, to apply it to the domain itself. Other bad coding practices are incomplete unit tests. I talked about it before a little bit. Code coverage doesn't say everything. I've seen a lot of projects that are already proud about their unit testing because they had like 98, 100% code coverage, but in the happy flow. Oh yes, you have covered all your methods, but you didn't really test your methods. That's bad, because if you want to refactor stuff, you are going to break things because you have not a good code coverage. And then this little quote. It's not from a code base I've seen for real. It's something from the internet. It'll take a minute to read it. It's bad for multiple reasons. For starters, it's too complex. It's the wizard, the abracadabra principle. There's this gray, hairy, weirdy wizard who wrote some code sometime, and nobody understands anymore what it means. The second thing wrong in this is people are not trying to improve it or change it or make it more comprehensible. They just add +1 every time they see this code. They're scared, probably because they aren't proper unit test for this, and nobody wants to waste its time on it. Entwining it, entangling this piece of code more and more in their code base, making it even harder to get maintainable code. Having said all that, now we come by some rules to code by. Starting with avoiding common mistakes. Don't apply magic. Magic only lives in fairy tales, not in our programmers' world. Only for silicon and on our machines, that's some kind of magic. But we don't need to understand that. Our code should be magic-free. To dry or not to dry, that's a question. Be aware of when you apply dry and if it's really the same thing you are trying to apply it to. And don't rely on God. It's funny to say this in a church. He might be there, he might not be, but if you write code, he isn't helping you. Go for readable code. I've said it before, code should be read like a book. You should be understanding it if you read through it. So if you jump on a new project, you can get a head start by just reading it. It's syntax. Syntax is how you build a language. The language we speak is a syntax. Coding is a syntax. Use it likewise. Yes, the flying V. Does anyone understand what I mean with the flying V? I have a little example for you. And it can get worse. I think these are about 6 indents. I've seen them up to 12, 15 indents. With switch cases, try-catch errors with even more if-else loops. It's horrible. It's not only unreadable, you have to scroll to left and right. And you could probably split up half of the code in a few methods in helper classes that can help you do this. So always avoid the flying V unless you're a guitar player and play in Van Halen. Catch return early. I've seen a lot of code having huge blocks of code, waiting to return, even if it's invalid, even if there should have been a return somewhere to return at the end. Preferably avoid having to return early at all. Only call a method if you are sure your piece of code needs to go through that method. But if that is impossible for any reason, use it. For example, you need try-catch with a database connection, which could be timeout. Then it's nice to have a try-catch loop and do something with it. But in all other cases, I think it's easily avoidable to have to return something early because it's not valid for the current method you are working in. Be defensive in your programming. How many of you know about defensive programming principles? I see only 1, 2, 3 fingers. Defensive programming for me means think of your code as if everything you do goes wrong. Exceptions all around, things can't get parsed properly, so should have try-catch on the proper places. Try avoiding throwing exceptions on your catch, but do something else with your code. If you have an exception in your code, it doesn't mean you are not sure what your code does. An exception is, hey, something happened and we weren't prepared for this. If you have a good architecture in your code, exceptions are countable in one hand most of the time. Just use them wisely. I've said this before. Avoid lock-ins by libraries and packages, because the more you entangle packages, external libraries, the harder it is to get it out. There will come some time a library get deprecated. Will come a time you need more changes in the package you use, and upstream pushing merge requests, pull requests aren't accepted. So you need to build your own fork. You want to change it. If you have this lock-in, it's impossible to change it, or really costly. And eventually, we are all business. Money should be made, and it's really costly to have these lock-ins. The solid principle. I see one guy cheering. I hope this is not new for you guys. It shouldn't be. For who hasn't heard about Solid before? I'm happy. So I can easily ask you all to chant out the meaning of all these letters. The S stands for single responsibility. The open-close principle, list of substitute principle, interface segregation principle, and the dependency inversion principle. Basically, these are the object-oriented programming principles to write more maintainable code. It's a great framework, set of principles. Even though these are known by most developers and most teams I've worked with, they aren't applied all that much. If you forget about them, it's good to review these every once in a while if you're working on a project with your team. Use a retrospective or a moment for it every 3-4 months to see, hey, do we still apply these rules? We should apply. The unit testing again, don't just go for code coverage, go for case coverage. Reasons I said before. If you have a bug, you are working on your project, a new bug comes in, start by writing a unit test for that special case. Because it probably has to do with the case coverage that's not complete, and you had only your happy flow testing. Once you have your unit test for your bug, it's easy to fix it because you have a unit test who tells you when it's fixed, and it's easy to refactor all your code. And good code is testable. Oh, I think that's obvious. Refactoring legacy code. How many of you guys have really tried to refactor your legacy code bases? For me, it's always a bit like this, like wandering around, seeing a lot of stuff I need to change, but I don't know how. Don't be afraid, refactoring isn't scary. It's okay to break things. If you never break things in your code bases, you will never know what's wrong with it, and your code base will die eventually. Always try to be refactoring. If you're working on a new feature, fixing a bug, and you see something out of scope of your ticket, but it's an easy pickup, just go ahead, change it. It's Boy Scouts, Girl Scouts approach, and it helps getting your code base more maintainable. And of course, we all built proper unit tests, so refactoring shouldn't be scary because we know what breaks. How to keep writing maintainable code? Think ahead. It's easy if you have a proper project planning, thought well about how you want to implement things, and discuss this with the team. You shouldn't walk into any problems. And the trick is to do this recursively. Don't just do it at once by the start of the project and just keep programming, but keep evaluating the way you implement things and if it's still in line with your architecture. If it's not in line, it's okay, change your architecture. Keep your documentation up to date with the things you change and keep talking about it. Don't be the rock star. This applies to the Abracadabra wizards. I've worked with too many people who are thinking of themselves as the best programmer there is because they can write complex code. People like that are really helpful to get a project started real fast, but in the long term they slow the whole team down because they only know the code, and if they leave the company, God only knows. Eventually your code is as maintainable as your most junior developer in your team, because he should understand what's happening. Of course, there are exceptions for this. Of course, some things are more complex for a junior to understand, but this is your baseline. Next, monitor your code maintainability. It's really important. We have all these checks in place now. There should be some ambassador who keeps checking, hey, are we still maintainable? And if not, how can we solve this in maintainability in our code? I think of it as technical debt. We work with Scrum, and our Scrum board has a hack log. Everything that is not maintainable goes into the hack log, so we can pick it up if we have time left in our sprint And we have always some dedicated time to resolve maintainability in our code. It's always important if you monitor it to make it discussable, talk with people about maintainability, so people stay aware of it. Next to that, keep your ducks up to date. Like I said before, sometimes you implement things differently than once put down in the architecture, so you should apply these code changes, architecture changes in your documentations. Even if you change your style guide conventions, which eventually should happen, techniques improve over time, so should your code base be. Help. My code base is... I hope this is something that pops in your mind now, having seen all these slides. You probably have code bases that are quite shitty. And what to do now? First of all, don't panic. Everything is all right. The fact that you are aware of your unmaintainable code base is a great start, because you have something to talk about, you are aware of it, the elephant is out of the room. Rome wasn't built in a day. Maintainability comes with small steps. So don't try to fix it all at once, but at least try to get your technical depth in scope. Use bug fixes, small features to improve your code, like the Boy Scouts approach I mentioned earlier. If you see small things you can fix easily, go for it. And of course, don't forget to add unit tests for everything you build from now on. Never keep contributing to unmaintainable code. I've seen it way too much. You have this 9,000 line piece of code, and people need to fix something in there. So they add another 100 lines of code. The next developer comes, he sees, there are 9,100 lines of code. I need to fix this thing. And there are 9,120 lines of code. Never do that. Always try to break it loose, put it somewhere else. Put bypasses on your code to improve maintainability. Gladly, now we're living in a world with microservices, serverless architectures. Most big companies I know are now leaving their legacy code bases behind, and every new feature or bug fix they are building goes in some serverless architecture with a bypass, goes from the old code to the new code, with little steps improving the maintainability. What's left is to apply all that you've learned today and spread the word. Then we're coming to the conclusion, wrapping up. The takeaways of today. Set up code conversion and coding styles. Discuss these with your teams. Document these conventions and the planned code structure and architecture. Avoid the common mistakes, obviously. Set up linters. These tools help you to write code that applies to style guides. Ensure your code stays readable and comprehensible. You could check this with your most junior developer. Can he understand it? Pair programming helps ensure this part, because you have two minds working on one piece of code instead of one person writing all the stuff. And keep evaluating your code maintainability and keep the technical depth in scope. In the end, I think the most important thing, get the elephant out of the room, talk about the maintainability of your code. For closure, some further tips. The design patterns book from the Gang of Four. It's a quite thick book, but explains all the design patterns they thought of 20 years ago, which still applies today. If you haven't read it, if you haven't bought it, buy it, put it in your closet and read it every once in a while. Learn some functional programming. Like Baarle said, I've done stuff with Lisp and Clojure, and it really helped me writing more maintainable code, because functional programming enforces you to write maintainable code. Stuff like linting is included, stuff like avoiding side effects is included. It forces you to write simple, easy code. Although functional programming is really hard to learn, so be aware. Finally, there's a little talk from Rich Hickey. Rich Hickey is the inventor from Clojure. Simple made easy, and this was mind-opening for me. I would suggest to see that. Thank you. First of all, Werner, thank you for having me. Lemonade and Silverstripe, and I should thank Giphy for all the gifts. Are there any questions?